Alright, so today I'm going to try to explain some basic concepts involving the stack, and I'm going to be using pseudocode, so don't get too attached to my syntax. And I'm going to be using Intel x86 assembly language in AT&T syntax. So basically what the stack is, it's just a chunk of memory usually set aside to a function by the operating system. So let's say in our case we have a function called add, and this function add takes two arguments, a and b, and it just adds them together. So add is going to have a stack. Just say this is add stack. And let's also say that add is inside of main. Let's say main calls add, so int main, and let's say that some things happen above here and maybe some things happen down here, but really what we care about is what happens when we get to this line of our code. So when we get to that line of our code, when we first call add, what's going to happen is the arguments of add are going to get pushed onto its stack. So in what order? Well, it's going to be in the order of right to left. So first B is going to get pushed on, then A. And once those are pushed on, another thing is also pushed on called the return address. And the return address, basically what it does is it tells us where to come back after we implement this. So let's say the return address, let's say we finish running whatever add tells us to do, and basically the return address tells us that after you finish with add, make sure to come back here and do whatever main is telling you to do after add. So that's what the return address does. And so through on the stack we have a register called ESP. So basically what ESP is going to do is, so basically we're going to have a register called ESP, and ESP is going to tell us where the top of our stack is. So in this case, the topmost item of our stack is the return address. So this is where it gets confusing. The stack, the topmost item of a stack is gonna be at a lower memory address than the bottommost item of a stack. So if we think of, in our case, and in every case, so let's say in our case we have this as at one address 105 in memory, and let's say this is at 107. So this is the topmost position of our stack. So let's say our stack, we have, if we draw it in the way that we can visualize it better, it's going to be, the return address is going to be here. Then we're going to have A, then we're going to have B. So in reality, how we want to visualize the stack is like this. This is going to be the topmost item of the stack. So this is the top of the stack, and this is the bottom of the stack. So if we draw it this way, however, this would correspond to a lower memory address, and this would be a higher memory address. So a lot of people like to draw it in this way because it goes from low to high, and some people like to draw it this way because it goes from top to bottom. So it doesn't really matter which way you draw it, but just make sure that you're aware of this, I guess, counterintuitive aspect of the stack, where the top of it is at a low memory address and the bottom of it is at a high memory address. So and also remember that ESP always points to the top of the stack no matter what. Let's say we push another thing onto the stack. Let's call it C. Let's say when we're inside of the add function, we push this number, this variable C. So what's going to happen is ESP won't be there anymore, but ESP will be here. So I hope that helps. Thanks for watching, and I'll see you in the next video.